So here we are at functional groups, my most favorite part of organic chemistry. Now, what have we gone over? The properties of organic substances. We've gone over the hydrocarbons. We've gone over isomers. And now we're going to go over functional groups. So all functional groups are is this: you can put some different elements on the hydrocarbons, and that totally changes all the properties. Okay? So it's not just hydrogen and carbon. So the very first one we're going to go over, it's not called hydrocarbons, it's called halocarbons. And that's going to be Roman numeral 1. So, Roman numeral 1 for functional groups is halocarbons, and halo is short for halogens. And you know the halogens. Halogens in group 17, fluorine, chlorine, bromine, and iodine. So all this means is we put one of those on the hydrocarbon chain. That's it. And then we name it. So we're going to do a couple of those names, but first we're going to write down the definition of a halocarbon. So when a hydrocarbon contains either fluorine, chlorine, bromine, or iodine, it can't be called a hydrocarbon anymore because there's something added to it. All right? So now we're going to draw and name a few of them. So put down number 2. And by the way, this should be in your black notebook. So, what we're going to build first is 2,3-dichlorohexane. And you remember, if I give you the name, you got to build the trunk first. Hexane, 6 carbons. All right? Now, and since it ends in ANE, it's an alkane, so it doesn't have any double or triple bonds. We'll get to them a little bit later on. So, I'm not going to put the hydrogens yet until I put the chlorines in. So first of all, it goes 2,3-dichloro. So I'm going to put 2 chlorines in, one at the second carbon, one at the third. Then, and it looks like that. Okay, that's 2,3-dichlorohexane. All right, now I'm going to give you a structure and you got to name it. This will be number 3. Okay, so this one has a triple bond in it. So if it has a double or a triple bond, it's not an alkane. If it has a triple bond, it's an YNE. So now the first thing you have to do, I don't care how many branches, the first thing you have to do is circle the longest carbon chain that contains the double or triple bond and name it. That's the trunk. So here it is. So that's the trunk and that's the triple bond. The triple bond comes after the second carbon. So that would be 2. And then count the carbons, 1, 2, 3, 4, 5, 6, 7. So that 7 is hept. So this would be 2-heptyne. And there's a bromine, and if you look, 1, 2, 3, 4. So this is 4-bromo 2-heptine. Bromo 2-heptine. All right, we'll do one more, and then that'll be it for the halocarbons. So this is number 4. So this would be 2,5-difluoro-1-hexene. Remember, you got to build the trunk first. So it has an ENE ending. That means it has a double bond. So hex means 6. All right, there are your 6 and 2,5-difluoro. And we have 1 hexene, so it goes right here. So there's your double bond. Now look at how many hydrogens have to be off the first carbon. I already have 2 bonds there, so 2 hydrogens there. 1, 2, 3, 4. No hydrogens there. 2, 2, 1, 3. That would be 2,5-difluoro-1-hexene. And that'll be it for the halocarbons. Okay? So Roman numeral 2, and this is going to take a while, Roman numeral 2 will be the alcohols. And the alcohols on the hydrocarbon chain, you have to put an OH. And you've seen OH before, it's hydroxide. But you've seen it as a base. This is not a base. Remember, a base has to have a metal and then OH. That's a base. This is not. This has a hydrocarbon chain and an OH attached to it. So that OH is called a hydroxy group. Must contain a hydroxy group, and that means it has to contain an OH. Now, you know how to name alkanes, alkenes, alkynes. And halocarbons, you know you have to name those too. But this has a different ending. It doesn't end in ane, ene, or ine. All right? Because the word alcohol ends in OL. So in naming, this is how you name it. So, in naming it, you name it like an alkane, like methane, ethane, propane, but instead of the E at the end, you kick that out and put an OL. So the first alcohol, instead of methane, drop the E, and it's methanol. And that's what we're going to go for. For number 3, will be naming. And capital letter A, the first one we're going to do is methanol. And meth means got 1 carbon. So here's what it looks like. Instead of CH4, it's CH3OH. Here's the structure. and that is methanol, CH3OH. Okay? Number 2. There are many, many different alcohols, but basically there's only one that you can drink, and it is definitely not that one. Okay? This one, I'm going to tell you how it's made. It's made by distillation of wood. In other words, what happens is this. Methanol is a byproduct of making charcoal briquettes. Okay, you know those charcoal briquettes that you squirt the lighter fluid on and then it makes your fire and you can cook your whatever you're cooking on the grill. Well, what they do to make charcoal briquettes is they have a big kettle and they put these cubes of wood in there and they put a fire down below, but the fire never touches the cubes. So the cubes start losing their vapors and start turning black. Well, the vapors are captured and they are sent over to another building that's very cold. So these vapors from the wood come up and they get into the cold environment and they condense. And that condensed liquid is methanol. Okay? Now, number 3, you don't have to write this down, but it smells, tastes, and looks like alcohol. You can't tell that it's methanol. And you see this in the paper all the time. Some idiot sells the methanol to people and tells them it's just alcohol. Now let me tell you something. If you drink this, and you don't need to drink a lot of methanol, remember it looks, smells, and tastes like alcohol. Chances are the first thing that's going to happen to you is you will go blind. But that's a minor technicality because if you drink a little bit too much, you'll go blind, but then you'll die. So you cannot drink methanol. So you have to be very careful with unmarked bottles of alcohol. I wouldn't try it. All right? So you will absolutely die if you drink a lot of it. So first you'll go blind, and then if you drink too much, you die. So that is methanol. Methanol, CH3OH, made by distillation of wood. I mean, it's vapors from wood. Yeah, I definitely wouldn't do anything and drink anything like that. So if you go to a party and somebody has an unmarked bottle of booze, let your friend try it first. And if they go blind, don't drink it. Simple. All right, so that is methanol. Now the next one's the most important alcohol of all. This is capital letter B. Got 2 carbons in it. So remember, ethane, you drop the E, you add the OL, and it is ethanol. Ethanol. So here is number 1 under ethanol. This is what it looks like. So the structure for ethanol is 2 carbons, 3 hydrogens off the first, 2 hydrogens off the second, and we got the OH there. So that is the structural formula for ethanol. So what's the molecular formula? C2H5OH. C2H5OH. This is very, very important. Now we're going to talk about this quite a bit. Remember, methanol is made by destructive distillation of wood. This one, and you've had it in biology, if you had biology, ethanol is made by fermentation. Made by fermentation. And this is an organic reaction. And you absolutely have to know this one. So right now, underneath number 2, I'm going to give you the formula for fermentation. So, what we need is something with sugar in it. If it has sugar in it, chances are you can ferment it and make alcohol. And that's how they do it with grains to make beer. That's how they do it with grapes to make wine. I mean, dandelions have sugar in them. And you can make dandelion wine. You can make any type of alcohol if it has sugar in it. You can ferment it. So we start out with sugar, C6H12O6. We do need a certain yeast, and that's called zymase. And you can get that from, the skin of raisins. It's even in dirt. So you can get the zymase from anywhere. And the zymase will eventually change the sugar into this. Now, C2H5OH is your ethanol or ethyl alcohol. But something else is produced, CO2 gas. So CO2 is produced. But now if you look at this thing, this has 6 carbons in it. I have 2 there and 1 there. I only have 3 there. So to balance the fermentation, you got to have 2 molecules of that and 2 molecules of CO2. So that is the formula for fermentation, and that is your ethanol. Okay, now there's a couple things. I said you can drink this stuff, but pure ethanol is about 200 proof, and it is a vasodilator, which means it really opens up your arteries and veins, especially your veins and your capillaries. Most of you don't remember this stuff, but like in the Alps in Europe, they always had these big St. Bernard dogs with the keg of brandy, and avalanche victims, the dog would probably find the avalanche victim first, and the victim obviously was cold, wet, shaking, shivering, and all of a sudden this dog comes up with this brandy in it, and they go, oh, thank God, and they drink some, and what it does is it opens up all the veins and capillaries so their fingers, their nose, their toes, and everything else, their lips, feel warm. But the problem is this: when you're cold, your body wants to keep the heat right here. It wants to keep your heat in your core. So what happens is, and everybody's had this happen, if you get cold, your fingertips start turning numb, your nose, your lips, your ears, and your toes. Well, instead of the blood going all the way up to the top of your fingers, it shunts here to keep the blood warm. But if you are, like if you fall in the river on an April day or October day and you're cold and shivering, the last thing you should do was drink alcohol. Yes, you will feel warm initially, but what that does is it makes the blood go all the way up to the top of your fingers, to your lips, to your nose, and it is giving off heat into the environment. and you are losing core temperature. So, what's going to happen is this. If you're freezing cold, wet, damp, and you drink alcohol, it will hasten you for hypothermia. So those avalanche victims that drank all that brandy, usually when the people found them, they were dead due to hypothermia. So don't forget, alcohol is a vasodilator. It opens up the arteries, veins, and capillaries in your body. Okay? All right. So now, my next story. When I was in college, the drinking age was 18. And we were 18, 19 years old. But there were a bunch of us that were chemistry majors. And we tried to do things that no other people could do. So we said, hey, why don't we try to make alcohol instead of trying to buy it? And I volunteered. I said, okay, I think I know how to make it. Yeah. So anyhow, my friends got 4 gallons of apple cider. And apple cider's got a lot of sugar in it. And so I said, well, if we put raisins and a little bit more sugar in there, I think we can get that. We can get ethanol, and I forgot about the CO2. So my roommate and I had 2 gallons on one windowsill, 2 gallons on the other windowsill, and we put the lids on, and we saw the little bubbles coming up. We said, cool, look at that, it's starting already. Well, like I said, I forgot about this part. And we had the caps on very tight. So after about 2 days, we were sleeping one evening, and also we heard a pop, 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 pop. The lids blew off because the CO2 built up. And the curtains got soaked with apple cider and smelled terrible in there. So I said, okay, no big deal. We just put the caps on slightly, halfway. So the CO2 can now get out. No big deal. So now the CO2 can leave. So after about 2 weeks, our room smelled terrible. And we couldn't take it anymore. So I took a taste, and wow, what a zing. You know, and I said, oh, it's got to be ready. Man, that was the biggest zing I ever heard. It kind of numbed my tongue. So we brought all our friends up, and we had this big old party, and we drank all the 4 gallons. Well, things started to happen. Like, people started to throw up. And in fact, one girl threw up right on my record player. So as the disc went around, everything that she threw up went around. And I was really mad about that. But then people started getting diarrhea. So people were throwing up diarrhea, but everybody kind of had a good time. But everybody got sick. So the next day was Sunday. Everybody recovered. And then Monday, we went to class. And my chemistry professor goes, I heard you had a party. I said, yep. He goes, well, did you make the alcohol? I go, yes, I did. And he says, well, explain how you did it. And I said, well, I took some apple cider, I put some raisins and sugar in it, and I was making it, the lids popped off because I forgot about the CO2, so I put the lids slightly ajar. And he goes, you put the lids halfway on? I go, yep. He goes, did air get into the apple cider? I went, yeah, because we had to let the CO2 out. And he goes, oh. So he took the chalk from my hand after I had written this beautiful formula out, and he goes, here. So he did this, he crossed out the ethanol, and he wrote in this. That's acetic acid. I made 4 gallons of vinegar. There was no alcohol in it at all, because once the air got in there, it would switch to acetic acid. And I begged him not to tell anybody because I probably would have been beaten up. That's why everybody was throwing up and had diarrhea, because if you drink a glass of vinegar, think about it. It cleans you out. So that was the first and last time I ever tried to make alcohol. Okay? So that is ethanol, and you need to know that formula. Now, The next one, we have A and B, and now, you know, you have propanol, butanol, and all that other stuff. We don't have to go over that, but we have to go over two more. So this is letter C. And this is a very interesting one. I'm going to give you the structure. I'll give you the molecular formula and the structure. So, there's the structure, and it's got two hydroxide groups in there. Two of them. So, the molecular formula would be this. CH2OH CH2OH. Okay, so that's the molecular formula. You can also condense that a little bit. So you could put down C2H4OH taken twice like this. So how in the world will you name this? This is a crazy one to name, but you're going to name the next one down, so pay attention. So since I have two hydroxy groups in there, it will be dihydroxy. So watch how you name this. That's the first carbon, that's the second carbon. So the first name. One, two. One, two dihydroxy, two carbons, ethane. Now, I told you alcohols had OL at the end, but if you tell me the hydroxys where they come from, you don't need the OL at the end. The next name has the OL at the name. The OL at the end. So watch. The next one would be this. One, two. Two carbons, ethane. That's pretty wild. So, the next name for that is 1,2-ethanediol. Di means two, OL means there's hydroxy groups. 1,2-ethanediol. Now, everybody's heard of this stuff. Everybody. We use it in our cars. And if you have a leak and it leaks out, dogs, cats, whatever, if they lick it, it tastes kind of sweet, and then they'll die. So the correct name for 1,2-ethanediol or 1,2-dihydroxyethane, the correct name is antifreeze. Antifreeze, that's one of them that you need to know. So look at the two names. 1,2-dihydroxyethane and 1,2-ethanediol. Now, the next alcohol that we're going to do, I'll give you the structural formula, I'll give you the molecular formula, but you have to give me the two names. All right, so here we go. And this is letter D. And the molecular formula, if I put all the C's and H's together, will be this. C3, H, 1, 2, 3, 4, 5. OH, taken 3 times. So, you have to give me the two names, and you have to find out what the common name is. So, So you got to give me the two names and then the common name for this stuff. This is used quite a bit. All right? So that's basically it for alcohols. Now there's a couple more names if you want to put them in. If you go back up to the top in your black notebook, and remember we had this one. Methanol. If you want to open up a parenthesis, the other name for methanol is this. Wood alcohol, because it's made from wood. Remember, that's the poisonous one. And then for the ethanol one, open up a parenthesis. There's two different names. Since it's mostly made from grain, it's called grain alcohol or ethyl alcohol. So, methanol can be called wood alcohol. Ethanol is ethyl alcohol or grain alcohol. Okay? Okay, now, we're going to do one more, and then you got another assignment to do with the alcohols. I think this is letter E. Now, you have to get good at figuring out the structural formulas if I give you the molecular formula. So the first thing you have to do is count the carbons for the trunk. So I have this. I've got 1 carbon there, 2 carbons, 3 carbons. I got 5 carbons. So the first thing you do is build a 5-carbon chain. Now the next thing you do is you put in the stuff. So off the first carbon, you have 3 hydrogens. 1, 2, 3. Off the second carbon, you have a hydrogen, but you also have an OH group. Off the third carbon, you have a hydrogen and another OH group. Off the fourth and fifth carbons, you have 5 hydrogens. 1, 2, 3, 4. Oops, sorry. One, 2, 3, 4, 5. Now, how do you name something like this? Well, all you have to do is tell me where the OHs come off of. So you could name this 2, 3. There's 2 OHs, so you could say dihydroxy. Two, 3 dihydroxy, and then 1, 2, 3, 4, 5. 2, 3 dihydroxy pentane, or you can go 2, 3, like pentane and drop the E. Two, 3 pentanediol. Okay, so now I'm going to give you the molecular formula for one. You're going to draw the structure and you're going to give me the 2 names. So you have a couple things to do for alcohols. So here's letter F. Okay? So, CH3, CH2, COH taken twice, C3, H7. So don't forget, count the carbons, put down the trunk, throw your OHs on it, and then you have to build the structure. And you have to give me 2 names for the structure. Okay? So we've gone over halocarbons and we've gone over alcohols. So those are the 2 for this video, and you have 4 questions to do for me.